Hello, welcome to Unit 9, Lesson 4. I'm Professor Blackman. Today we're going to be talking about logarithmic functions. We're going to find logarithmic functions with and without a calculator. We're going to look at converting exponential to logarithmic equations and then going from logarithmic back to exponential. And we're going to use the change of base formula to change bases of logarithms. All right, so to understand logs, this one right here is very important. Um, when you have log base a of 1, that equals 0, and log base a of a equals 1. So if you don't see a number down here, there's always an understood 10 right here. So that is our natural base for logs because uh, our numbering system is in base 10. So since this is log base a of a equals 1, log base 10 of 10 equals 1. So log of 100 um, is 2. Log of 1000 is 3. Log of 10,000 is 4 because 10 to the first power is 10. 10 right here to the second power is 100. 10 to the third power is 1,000. 10 to the fourth power is 10,000. Log of 1 is 0 because 10 to the 0 equals 1. And so then we can even go log to the 1 over 10, which is -1. Log to the 1 over 100 is -2. Because when we're looking at problems like these, we're using this idea that logarithm and are exponents. And understanding what logs are is very helpful if you understand how exponents work. So let's go ahead and get started on some examples. All right, so log base 2 of 16. Well, 16 is equal to 2 times 2 times 2 times 2, which is 2 to the fourth. So this can be written as log base 2 of 2 to the fourth. And so this equals 4. Because if you can take this number of 16 and put it in the base of 2, you can quickly see that this 2 of 2, this gives you a 4. So now how could we rewrite 2, this 1/4 in base 2? Well, if you have 1/4, it can be written as 1 over 2 squared, which is 2 to the -2. Take that negative exponent, kicks it to the bottom. So if it's the bottom, you can make a negative exponent and it kicks it to the top. So this log base 2 of 2 to the -2 makes this equal -2. And then this is natural log of 1. And if you remember on the previous slide, we know that this always equals 0. Natural log is log base e of 1. This means the same thing. So this is an understood, it's ln, which is natural log because it means logarithmic natural. But this is, whenever you see ln, that's natural log. That's log with base e, which is a universal concept that occurs a lot in nature. All right, let's look at some more examples. Okay, so how do we take this 3 and put it in this base of 3. Well, this is the fourth root, and if you remember, this could be written as log base 3 of 3. If you remember, we have the exponent. We can rewrite this as a fractional exponent. So if you have, this is n, this is an m, then that is equal to x to the power of m over n. This is m is your power and n is your root. So this is 3 raised to the power of 1, or 1/4. So this 3 and 3, this gives you 1/4 right here. All right, this is base 10 of 10, so this is just quickly -7, because that 10 here and that 10 there. Remember, there's an understood e right there, so e to the 3, this equals 3. If you can take your base of your number that you're finding the log of, and it matches the base that is here, it just equals that exponent. All right, on these examples, we are going to be switching them from exponential to logarithmic form. So you're basically taking them from exponents and putting them in the logarithmic equation. So we're going to start by putting log, and then we look at this formula right here that's given to us and match up the parts. So the base of A is the base here, 8, and then the big number x is the x that's by itself, and then this equals 1/3. And then you can always quickly check with these if they're all numbers. 8 to the 1/3 is 2, so this base and that all makes sense. All right, this one is base e, so we're going to use natural log, and the exponent up here, the y, is what goes over by itself. So then this is ln of t equals 3. Here we have a base of 5, so we're going to do log base 5. And then x, that big number, is the stuff that's by itself. So that's the 1 over 125. And then that all equals -3. So 5 to the -3 equals the 125. All right. So now we're going to do the reverse. We're going to switch from log to exponential. So base 5 becomes the base. The term by itself, this 1, which is the y, becomes the exponent, and that equals 5. And mathematically, that makes sense. Base 4, exponent of 2, equals your x, which if we need to solve this, we could quickly find out that x is 16. Ln, remember Ln has base e, so this is e to the 3.4012, and that equals 30. And you can probably check that on your calculator, maybe a little off because of rounding. All right, here, this is change of base form. So if you needed to find a decimal approximation for something, you would do this. So you do log base b of m is equal to log base a of m divided by log base a of b. So you can use any base. I recommend using the base of 10 because that's the one that's on your calculator. So it's basically the log of the big number divided by the log of the base. So then this equals log of 100 divided by log of 4. This equals log of 50 divided by log of 200. All right, let me pull up a calculator. Now, depending on what type of calculator you're using, sometimes you have to type the 100 first. Sometimes you have to type the log first. But for this one on the computer, we have to type the number first. So 100 log divided by 4 log. But a lot of calculators, you'll just type log 100 divided by log 4. And what we get here is, rounded to 4 decimal places, is 0.602. And then that fourth decimal place is a 0, but the fifth decimal place is a 5. So this is 0.6021. And then let's try the other one. Log of 50 divided by log of 200. And in that case, we get 2.3010. Fifth decimal place is a 2, so it's not going to round it up. All right, that's all I have for you today. Happy studying.